All right, well, let's talk about symmetry. Now, we can have either line symmetry or we can have point symmetry. And line symmetry, an easy way to think about it is if we were to fold the graph in half, would it match up evenly? And with point symmetry, if we were to rotate the graph 180 degrees, would it then appear to be unchanged? And so here, before we get into some specific examples, let's just look at three examples here of symmetry. Now, in this first one here on the top, when I look at it, well, I can fold it. If I look at it, if I folded it along the x-axis, then it would match evenly. And so then we could say that it is symmetric with respect to the x-axis. And that for every point x and y on the graph, the point x negative y is also going to be on the graph. And so we can also do an algebraic test, and that is if we replace y with negative y, we get an equivalent equation. Now, in the middle, I see that it is symmetric with respect to the y-axis. And again, think of it this way. If I were to fold it along the y-axis, then it would match, and it's got symmetry. And so for every point on the graph that's x and y, negative x and y is also negative x comma positive y is also on the graph. And so algebraically, if we replace x with negative x, it produces an equivalent equation. And then finally, we've got symmetry. This last one is symmetry with respect to the origin. And if we were to rotate this graph 180 degrees, I think I went further than 180 degrees, then it would appear to be exactly the same. Let me erase part of that. If I were to rotate this 180 degrees, and then this one would rotate down 180 degrees, it would appear to look exactly the same. And so for every point x and y that's on the graph, well, then negative x and negative y is also on the graph. And an algebraic test, if we replaced x with negative x and y with negative y, then we would produce an equivalent equation. So let's look at a couple here and see if we can determine the symmetry. So in this first graph, which is the equation negative x squared plus 6, and I look at that graph and I think about, well, what if I folded it along this y-axis? Would it appear to match? And it would. And then if I wanted to further test this thing, let's look right here where x is negative 1, y is 2, and where x is positive 1, no, that's 6, isn't it? No, that's 2. Where x is positive 1, y is also 2. So when it's either x, negative x, or x, 2, negative 2, or 2, the result is the same. Y is equal to 2. Negative 1, I think I said negative 2. Negative 1 or 1, y is equal to 2. And so when we can say that this then is symmetric with respect to the y-axis. Now, let's look at this second graph. One, this is not a function because it could not pass the vertical line test. And we can also see from the equation where we got this y squared, it's not going to be a function, but it's x squared plus y squared equals 25. But does it have symmetry? Well, again, and just visualizing that, if I fold that vertically, it would appear to match. And if I folded it horizontally, it would appear to match. But let's take a closer inspection here.
To a mattress bed.
And that is, what do I see here on the graph? Hold on just a second. That was weird. My TV started to restart itself. Well, let's look right here at this point right here, where x is equal somewhere between 4 and 6, and y is 0. And then when y is 0 down here, negative, it's also between 4 and 6 and would appear to be about the same difference. Now, what about when we're evaluating the horizontal axis? I mean, the horizontal axis, the x-axis. Well, when y is 0, I see that x is, I don't know, maybe -5. Yeah, it looks like -5. And when y is 0, also when y is 0, also when x is 5. In fact, I could plug that into the equation. Let's see, if I put 5x squared plus, and y is 0, 0 squared, well, x squared, 5 squared is 25. And -5 squared is also 25 when y is 0. Let's go the other way. How about when x is 0 and y is +5 squared? Well, that's 25. And what about when y is -5? Well, -5 squared is also 25. And so here, interestingly enough, this is a circle, but we do have symmetry with respect to both the x and y axis. All right, pretty cool. Symmetry. Think about folding it or rotating it, and there it may be. Actually, if it goes to the origin, it might be symmetric at the point of origin. Test for symmetry. Shazam.